All right, guys, welcome to the lesson on 7.1, Part B. So just like with Part A, we're going to start with some vocab before we move on to our new theorem. All right. So first, all sides of a polygon being congruent. Okay, so that's going to be noted when they draw the picture by drawing these single dashes. Remember, if there's a double dash and single dashes, that means those are two different lengths. So if all of them have the same single dash through them, that means all the sides are congruent. They're all the same length. We call that an equilateral polygon. Okay, you might remember an equilateral triangle meant all of the sides are equal. Equilateral polygon means all sides equal. Equa for equal, lateral for lines. So length of lines are all equal. Second middle term, okay, all interior angles are congruent. So if all the interior angles are congruent, we're going to have this little one dash on all of the angles. Remember, if an angle was a different measurement, it would put a second little loop out there, or they might put a little dash through it, okay? But since all of those angles have the same little curve to them, that means they're all the same measurement. So they're all congruent. We call this equiangular. So all angles are equal. All angles are the same measurement. So if all sides are congruent, it's equilateral. All angles are congruent, it's equiangular. If both all the sides and all the angles, so if it is both equilateral and equiangular, okay, we call that a regular polygon. Okay, so regular polygon, if you're reading the description or the text and it tells that you're dealing with a regular hexagon, okay, that means all the sides and all the angles are equal. All right, so let's look at example 4. A home plate for baseball field is shown over here on the right, A, B, C, D, E. It says, is this polygon regular? Well, first I'm going to look at it, and I don't see any markings on the sides being the same length, but I do see markings on the angles. I notice E and C have the same marking, but A, B, and D are all indicated to be right angles. E and C were not. So I'm going to say no, this is not a regular polygon because the angles are different. Because angle E is not the same thing as angle A. All right. To be a regular polygon, all 5 of those would have to be the same angle, and 2 of them are different than the other 3. So now it's telling us, find the measure of C and E since they are different. I'm going to go back to what we learned yesterday in 7.1. I'm going to say, well, this is a 5-sided shape. So I'm going to use my equation of n minus 2 times 180 to figure out how many total degrees should be in this pentagon. So 5 minus 2 times 180 is the same as 3 times 180, which equals 540. All right. Looking at this, I know E and C are the same measurement, so I'm going to call them X. A, B, and D are a different measurement, so I could call them Y, but fortunately they gave me this little box. Remember that little box means that it's a right angle, so each of those equal 90 degrees. So I have X plus 90 plus 90 plus 90 equals 540. X plus X is 2X. 90 plus 90 plus 90 is going to be 270. Okay, I've got multiplying by 2 and adding 270 to solve for X. We're going to undo adding first. So I'm going to subtract 270 from both sides. And I get 2X equals 270. So 540 minus 270 is 270. Now I'm going to divide by 2, and x is going to be 135. So the angle E and angle C are both 135 degrees. So new content is going to be the polygon's exterior angles theorem. Okay, so we talked about these interior angles in there. Okay, so normally when we have a shape with interior angles, if we continued each of those angles to make a straight line, all right, so if we were dealing with a rectangle, okay, if I just took each of my angles and continued them out, we call those exterior angles. Okay, so exterior angles means I'm taking these lines that make up my polygon, and I'm going to extend them just a little bit farther. And opposite the interior angle is the exterior angle. They form a straight line. All right, and what this theorem's telling us is that no matter what type of polygon I'm dealing with, as long as it is convex, if I add all of my exterior angles together, they're going to add up to 360 degrees. So that is true for all polygons. Okay, so true for all polygons. Big caveat is they have to be convex. They have to have all interior angles that are less than 180. If your interior angle is larger than 180, so we're dealing with that guy we took notes on earlier. Okay, this interior angle here is already bigger than 180. So if I were to continue this line inside, that's not really an exterior angle that we've made. Okay, so this only works with convex polygons. It doesn't matter how many sides it is. It's true for all numbers of polygons. Okay, so example 5 says find the value of x in the diagram. Well, I see x are these exterior angles. I know that no matter how many sides my polygon has, I can add all my exterior angles together. And they're always going to sum to 360. Okay, we can combine like terms. So 2x plus x is 3x. 67 plus 89 is 156. Okay, I'm going to subtract the 156 first. So 3x equals 204. Divide by 3. My value of x is 68 degrees. All right, this one just said find x. It didn't say to find the angles. So I'm going to stop right there. But if it said find the angles, we'd have to go back in and plug those in to confirm. But this one did not. All right. Example 6 says we're going to look at this trampoline over there, which is a regular dodecahedron. Okay, but the fact that it's saying regular, remember, means that all my sides are going to be the same length. More importantly, all my angles will be the same length. Okay, so since all my angles are the same length, I'm going to be finding the measure of interior angles. Well, each of those angles I'll just call x. Okay. So I know there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So n equals 12. Before I can start figuring out what each of the x's are, I need to know how many degrees are inside this shape. So n minus 2 would be 10. 10 times 180 is 1,800. So I know that if I add all of my x's together, I'm going to get 1,800. Since all my x's are the same side, I can just do x plus x plus x plus x plus x and end up getting 12x equals 1,800. Divide by 12. So each of my angles in there, each interior angle is going to be 150 degrees. Okay. Now we're going to look at exterior angles. So if I extended each of these lines, okay, I'm going to have each of these exterior angles. We're going to call all of them y. So x plus y would equal 180. So since all my interior angles were x, my exterior angles are also all going to be the same size. I'm going to have 12 of those. And if I add all of those together, this is a regular polygon. This is a polygon. Exterior angles of polygons always add to 360. This time I have 12y equals 360. We're going to divide by 12. So each of my exterior angles is going to be 30 degrees. Question 7. Kind of asking us to do the same thing. So this time it says find the measure of the interior angles and each exterior angle for a regular. Keyword here is regular. So all angles are going to be the same again, of a 15-agon. So n equals 15. All right, we're going to do interior angle first. So I need to figure out how many degrees we have. So my equation is 15 minus 2 times 180. So 13 times 180. Total number of degrees I have inside my shape is going to be 2,340. I'm going to look at, well, if I take the 15 interior angles, and I add them all together, so x plus x plus x plus s plus s plus x plus x plus x plus x plus s 15 times, they're all going to add to 2,340. So we'll divide by 15. So each of my interior angles is going to be 15.6 degrees. Which actually seems way too small. So let me grab my calculator and check my work. So 2,340 divided by 15 is 156. I think I left a 0 off when I typed that in the first time. So 156 degrees is each of my interior angles. All right. I'm going to jump over to exterior angles. So my exterior angle, again, I know I'm going to have 15 of those angles. But this time when I add them all together, I'm going to get 360. I'm going to divide by 15. So the measure of each of my exterior angles, 360 divided by 15, is going to be 24 degrees. All right. So exterior angle theorem just means that if I'm summing all of my exterior angles, as long as it was a convex polygon, all my interior angles were smaller than 180, no, they're going to, exterior angles will always add to 360. All right. So you guys do have an assignment over on Big Ideas. If you guys need any help with that, let me know. Otherwise, hope you guys have a great weekend. I will see you all Monday.